Okay, what is a limit, and what do we mean mathematically by this term limit? I'll explain this in the context of a particular example. Let's look at a function. F of x is x plus 2. We'll take a pretty simple function. Now let's go ahead and graph that. That's going to go through the point 0, 2 and the point 2, 4. Has a slope of 1. So this is a very simple function. It looks like this. The key point of a function, remember, is that we can plug in some x value and using this little formula calculate a corresponding y value or a corresponding height of the function. And for any given x value, it has a certain height. Think of a limit as the y value or the height toward which the function is heading. So let's look at a specific point right here, for example, x equals 2. At that x value, if this is drawn accurately, we have a y value of 4. And we can express that pretty easily by saying f of 2 equals 4. Now that's obvious, but to think about the idea of a limit, think about the x value getting close to 2 but not quite getting there. So imagine moving along the x-axis and we're getting really close to 2 but not quite getting to the value of 2. And as we move along the x-axis, you can imagine moving along the corresponding points on the function. And so we're getting really close to this point right here, but never getting quite to it. As we get close to an x value of 2, we get close to a y value of 4. That's what we mean by a limit. We don't actually have to get to 2. But as we approach an x value of 2, the value of the function approaches a limiting value of 4. Now this seems pretty obvious in this case. The value of the function at 2 is 4. That's what that point on the graph right there means. So why do we even need to state this? Well, the reason is there are some cases where we can't actually get to the value of the function at that point. Take a look at this function, which is actually very similar. F of x is x squared minus 4 over x minus 2. And let's graph that. And don't look at this x squared and think, parabola. We need to simplify this. If we simplify this, you might recognize very quickly we have the difference of two squares up there, so that factors as x plus 2, x minus 2 over x minus 2, and hey, these guys cancel out. And we're left with this, x plus 2. So that's the same function we had before, except we can't have a 2 down there, because a value of 2 for x would give us a 0 denominator. So we can't have an x value of 2. So if we graph this function, when we get to this point, we have to have a hole in the graph right there at the point 2, 4. Otherwise, the graph is the same. It's just the line, y equals x plus 2, but there's a hole in the graph right there. So now if you try to do this, if you try to say f of 2, well, what's the value of the function at x equals 2? It's undefined. The value of the function is undefined at x equals 2. You can't plug in a 2 and calculate the corresponding y value because you can't divide by 0, and 2 minus 2 is 0. However, even though we can't actually plug in a 2, we can imagine getting really close to 2. And so if you imagine moving along the x-axis and your x values are getting really close to 2, then your y values are getting really close to 4. So even though we can't make the x value 2, we can make it as close as we want to 2. And we can correspondingly keep our y value as close as we want to 4. A mathematician would say we can make the value of the function arbitrarily close to 4 by keeping our x values sufficiently close to 2. And the way we say this mathematically is we say the limit of the function as x approaches 2 is 4. And we write it like this, and you should write this in your notes. The limit as x approaches 2 of f of x equals 4. And this is really easy. This isn't a difficult concept. This is mainly a matter of notation, how we write it. What this means is that as x gets really close to 2, this function f approaches a limiting value of 4. And you see that on the graph. And again, picture in your mind, picture moving along the axis. You get really close to 2. You never quite get there, but you get really close. And as you do that, the y values get really close to 4. the limit of this function as x approaches 2 is 4.